So some review for chapter 15. Some skills you need to know is how to raise a matrix to an integer power. So we did this a little while ago, way back in the fall. So here's your matrix, 2, -1, 1, 0. If you were to square it, basically that just means just like if you were to square anything else or raise it to the third power or the fourth or the fifth, etc. You're going to take and multiply these two numbers together to get here. Then you're going to multiply these two numbers and then that combine to give you this single entry right here, like that. And you'd continue, so same deal is that I would multiply these two numbers by these two numbers to get this entry right here, these two numbers by these two numbers to get this entry right here, and these two numbers by these two numbers to get this entry right here. That becomes quite cumbersome, so you might want to remember using desmos.com/matrix. And you can just enter a matrix and then raise it to a power. You could raise it to like the 17th power and it would just do that same thing for you. So that's one thing. The second thing is being able to find the steady state vector for a transition matrix. So let's start with just what a transition matrix is. Here's a silly example, but it works. If it is sunny today, the probability is sunny tomorrow is 70%. If it is cloudy today, the probability is cloudy tomorrow is 40%. So what that might look like is we're going to examine today and it's either going to be sunny or it's going to be cloudy. And if it is in fact sunny today, the idea that it would be sunny tomorrow is a 70% chance, which then presumably means that I've got a 30% chance of cloudy tomorrow. In this world, there are only two states that we could exist in. So if it's cloudy, we got 40, which would get us 60%. You could also draw this as a like sunny and cloudy, where we say that there is a 70% chance that it repeats to be sunny, or a 30% chance that it is cloudy, a 40% chance that it repeats to be cloudy, or a 60% chance that it moves over to sunny. And so what this looks like as a matrix, sunny, cloudy, is that if it is sunny today, the idea that it would be sunny tomorrow is 70 and 30, 60 and 40. So you'll notice that these will always sum up to 1. The columns will always sum up to 1. And like this entry, this 0.6, which I've drawn very badly. There we go. This 0.6 would mean that the probability it is cloudy today but moves over to sunny tomorrow is 60%. So that's what a transition matrix is. And to get a steady state vector, what that would mean is that if we have some matrix is square and regular, there's a unique vector such that that matrix multiplied by that vector is equal to that vector. This is Q, and it's called a steady state vector for P. And here's about how you would go finding that. Here's my square regular transition matrix, right? Adds up to 1, adds up to 1. Cool, it's square because it's a 2 by 2. Awesome. You're going to set this out as we're going to solve for the x values. So here are my my x values. We're going to take 0.1x plus 0.6y, so just straight across the top here, and set that equal to x, because we're going to get our x value in the top row. Our y value is going to come from the bottom row, so we're going to say 0.9x plus 0.4y equals this. You'll notice both of those give you the same relationship, right? If you subtract 1/10 over here, subtract 4/10 over here, as you like. We basically end up getting like x is the same as 2/3 of y from either of these equations. Pause and check that if you would like. Then we're going to add this function because we know that they have to sum up to 1. So x plus y is 1, and then these two is really what I'm going to end up using to solve for my steady state transition. I'm just going to solve that. So in this case, it's just a system of equations. I subtracted y, I substituted it in, and I got that y would always be 3/5 and x would be 2/5. So my steady state transition vector q, in this case, q would be x is 2/5 or 4/10, and then 6/10. And you will find that if you try this out, that p multiplied by the vector q is equal to the vector q. Let me know if y'all have questions.